So let's begin. So the distributive property gets used constantly whenever we're simplifying algebraic expressions. Now, that means you basically take what we were doing yesterday, just take a longer variable expression and a piece of math with lots of variables in it, just make it smaller so we can work with it. Okay? So the distributive property is used when we have something like this. We're basically multiplying some sort of coefficient by two or more terms. Okay, and what's going to happen is you distribute. You literally take whatever A is, and it's multiplied to every term inside. So we would have A times B, and then A times C. Okay. So the thing is, there's a few ways when you're first learning how to use this property, how to understand it. So we're going to use what's called an area model. So you probably used area models before. That's where you use the concept that the area of, say, a rectangle is length times width. You guys remember doing that? So we're going to go ahead and use this for simplifying using the distributive property. So let's just kind of get right into it. We're going to simplify the expressions by distributing. Okay. But we're also going to use an area model. This is going to help us, especially next year when we start multiplying polynomials. We'll learn what those are. That's an algebra thing we'll do next year. And when we start factoring polynomials, again, next year. But we're going to lay the groundwork for all that this year. Okay? So let's begin. Let's say we want to do the following. We have 6, and we're going to multiply 6 times two terms. The terms are 3x plus 2. But I want to show you how to get the answer using an area model. Okay? So tell me if this looks familiar. Below this, I'm going to write the area model. We're going to take the 6, and that's going to be like our width. And then we're going to have a rectangle. And then I'm going to split it in 2 because we have 2 terms. Okay? And then the width is going to be the 3x. And would you say that's a positive 2 or a negative 2?
Positive.
Positive. Plus, positive, minus, negative. Okay. So we're going to write 3x and then positive 2. Now, inside, we're going to fill in the area by multiplying. Have you done this before? It looks familiar? Okay. All right. Well, let's do 6 times 3x. Let's see what we get. 18x. You multiply the coefficients together. You get 18x, 18 times x, but we say 18x. And then you multiply 6 times 2. 12. So we get 18x and positive 12x. So over here, we write down that answer. 18x, that's one term. And the second term was positive 12. So that would be written as plus 12. Okay? Do me a favor. A couple of you have their Chromebooks. Close them up. Close them up. No need to have them open at the moment. Okay. Any questions on that? No. Okay. Let's try another one. Number 2. We're going to multiply 2 with 5n plus 2.5. Okay. So the quantity 2, we're going to multiply it with 5n times 2.5. So let's set up the area model. We're going to do 2. And then we're going to figure out the area. That'll be the answer, basically. Over here, it's 5n, and then positive 2.5. So let's go ahead and figure out the area. Multiply through 2 times 5n, and then 2 times 10n. 5. 2 times 2.5 is 5. So that gives us an answer now. 10n plus 5. Okay. Let's try a few more. What are we up to? 3? Negative 4. I think we're ready for some negatives. We're going to multiply that times negative k plus 6. Okay, so we have to be a little more careful here because we do have negatives. Let's set up our area model. So what am I putting on the side for the width? A negative 4. And across the top, we would put negative what? Negative k and a 6. I don't have a coefficient right here. I could put a 1, making it negative 1. And that's important because now I got to multiply. And look what I'm multiplying. Negative 4 times negative 1.
Positive 4k.
Positive 4k. Okay, so all those rules apply. Positive times positive is positive. Negative times negative is positive. How about a negative 4 times a positive 6?
Negative 24.
So we got 4k and negative 24. So when we go to write our answer, it's going to be 4k minus 24. Any questions? All right. Let's go ahead and try number 4. Negative 8. And we're going to multiply that by 3m minus 1. Okay. So let's set up an area model. So negative 8, 3m.
Negative 24m times plus 8. Plus 8.
Negative 24m.
24m plus 108.
Negative times negative is positive. So that's just 8. Negative 24m and positive 8. So over here,
-24 plus
Is it negatively or
8.
8?
8.
It's 8. So excuse the dot there. I realized I was making my 8 too big too late. Oh well. It's positive 8, right? So plus 8. Okay. So no, got a few more. Want to explore a few more decimals. -9, and this time we're going to multiply that with 5.5p plus 2. So -9 times 5.5p plus 2. Let's set it up. -9 and then 5.5p and 2. Okay, so we got to multiply -9 times 5.5.
45. No, 49.5. Negative 49.5, right?
Yes, -49.5.
How is 50?
No, that's negative. That's negative 10. Good. Oh, wow.
Well, look, let's see. -9 times 5 is -45, right?
Yeah. And then negative 5 times 0.5 is 4.5.
4.5.
Negative
Yeah,
4.5.
half of 9 is 4.5. So you would add those 45 and 4.5
Which is 49.
and
5p.
49.5. And then how about -9 times positive 2?
Negative 18.
Okay. So in the end,
And then
we get two terms. That's the part that gets a little tricky. We get two separate terms that are either adding or subtracting. We've got negative 49.5p and then minus 18.
yeah.
You have to be comfortable with the fact that a negative here
Is your minus over there?
is a minus over here, and vice versa. A positive here is a plus over here. Okay, if you're good with that, that's about the trickiest part. Okay,
That's the trickiest part.
of this,
Pretty easy.
I mean, the only thing that would make this a little harder is if I add more terms. We've been doing 2 terms. We could do 3
What
terms.
did that spread it into like fourths?
4 terms, 5 terms. This we could go on, right? Let's just do 3 terms. Number 6. Let's say we have 3, and we multiply the 3 to x, take away 10y plus 2. So we're going to be up to 3 terms. Just going to make our rectangle a little longer. So we're finding the area when we have 3 terms. Split it up into thirds. We got 3x negative 10y and positive 2. Okay, let's see what we get. First of all, 3 times x.
3x.
That's easy. How about 3 times negative 10y?
Negative 30y. And 6, yeah.
And then 6.
This is easier.
Yeah.
So we've got 3x minus 30y and then plus 6. Okay. We'll do a couple more. And then we'll call it number 7. -8, and we'll multiply that times 3v as in Victor plus 5w minus 10. Let's try that one. Okay, go ahead and try it. Do it on your own.
Yeah.
So the first one we're going to multiply is negative 8 times 3v. Then we'll do negative 8, negative 40w.
What does minus translates to minus?
So that'll translate to a minus. And
Then-
finally, negative 8 times negative 10, or
Plus
minus
80.
10.
Plus 80. 'Cause it's a
Yes.
positive.
You'll have to wait. Okay? Not too bad. This will be the last one. Number 8. Negative 3.5. And we're going to multiply that times negative h
Ooh.
plus 2k minus 8. Okay? All right, gentlemen, come on. Work on this. So let's start by multiplying in an area model, and then we'll get the answer. So
So negative 3.5 times negative h. Isn't that just 3.5h?
well, we are multiplying a negative times a negative, right?
So it becomes just positive 3.5h.
Mm-hmm. So let's start with that. 3.5h. Then we're going to multiply negative 3.5 with plus 2k.
Minus 7k.
Yeah.
Negative 7k.
Yeah, that's a negative times a plus, so that's minus 7k.
And then negative 3.5 times 8 is
26.4.
no.
Well, you got 3 times 8, that's 24. And what's
Yeah.
half of 8?
28.
28.
It's 28. Yeah.
And will it be positive or negative?
Positive.
So plus 28.
Yeah.
So there you have it. Okay. So the assignment is on Delta Math. Some of them are going to be using area models. Some of them won't. But hopefully by now you're comfortable enough
Oh yeah.
that it shouldn't be too bad.